Good evening and welcome to Pacific Science Center's virtual Science in the City. I'm Zita Strickland and I'm pleased to be your host for tonight's program, our virtual Science in the City talk. Science in the City was made possible with generous support from Jeff and Carmen Barr. Additional support comes from more than 1,500 individuals, companies, and foundations that donate to Pacific Science Center each year. Tonight's Science in the City presentation will be recorded for later viewing on our YouTube page. And on that page, you can find all of our past Science in the City talks. For example, if you have perhaps an upcoming trip that you have planned, you can rewatch our recent Flying in the Time of COVID-19, or you can learn about the science inside Climate Pledge Arena in advance of the upcoming Kraken hockey season. All of these past Science in the City talks can be found on our Science in the City playlist on PacSci's YouTube page. In addition to these past Science in the City events, on our web pages, you can also find activities that can be done at home or in the classroom, and information on our live and interactive summer camps and virtual field trip programs. You can learn more about all these programs at pacsci.org. Thank you very much for joining us tonight and for being curious with us. Thank you also to everybody who made a donation at the time of registration. If you haven't yet and would like to donate, you can at pacsci.org/support. Your donation helps us to ensure that curiosity never closes. Now, tonight's event, our Science in the City, is a multi-angle look at a central topic, earthquakes here in the Pacific Northwest. And with our panel of experts, we're going to be looking at the new ShakeAlert system and how its creation and its implementation is informed by both seismology and by social science. Now, throughout the event tonight, you can share your questions to our speakers by adding it directly to the YouTube chat box on the screen. If you don't see a chat box on your YouTube screen, it just takes a moment to create a YouTube account so that you can leave your question for us to ask of our great panel of speakers tonight. I'm happy and excited to introduce our guests as I give you an overview of tonight's program. You see, ShakeAlert is a huge effort over many, many regions, and getting the word out to that many communities about earthquake preparedness and about ShakeAlert in general needs a coordinated and comprehensive communication, education, and outreach program. So joining us tonight from the United States Geological Survey is Mariah Jenkins. Her work includes assisting with the overall communication and the outreach of ShakeAlert, including the development of educational resources with a focus on diversity, equity, and inclusion. Also joining us tonight is a look at how these communication plans are informed by an understanding of risk perception and science communication. And so I'm pleased that we're joined by Dr. Ann Bostrom, University of Washington professor and fellow of the American Associations of the Advancement of Science, the Washington State Academy of Sciences, and a fellow and former president for the Society of Risk Analysis. Excellent, welcome Ann, thank you for being here today.
Thank you for inviting me. It's a pleasure to be here, Zita.
So excited. Also joining us is Dante DiSabatino. He's an earthquake early warning outreach coordinator for the Washington State Military's Department of Emergency Management Division. Dante has a master's degree in infrastructure planning and management with a focus on, this is why he's so perfect to be joining us tonight, a master's focus on the community-driven resilience and emergency management. And his area is ensuring that we know how to get alerts from the system and how you can protect yourself when an earthquake happens. So thank you for joining us today, Dante.
Thank you for having me.
Now, finally, and to start our conversation tonight, we have Harold Tobin, the Paris Professor of Seismology and Geohazards at the University of Washington and the Director of the Pacific Northwest Seismic Network. In this role, he also serves as a state seismologist for Washington and as the lead scientist for this state in the ShakeAlert Earthquake Early Warning Project. Harold studies Earth's major fault zones where plate tectonics collide, working to ensure how and why earthquakes and tsunamis occur, with a particular focus on the giant offshore faults known as the subduction zones. He's conducted field research around the world, all in earthquake areas, in land and at sea, including Costa Rica, New Zealand, Caribbean, Alaska, and Japan. Harold, I think that's actually one of my vacation wish lists of all those places, so I'm a little bit jealous of your travels, as well as study earthquakes right here off the coast of the Pacific Northwest. He now leads the new geohazards program at the University of Washington, founded just this year and focusing on hazards such as tsunamis, earthquakes, landslides, and volcanic eruptions. Harold, thank you so much for joining us tonight. I'm excited that you're kicking us off with an overview of where we are and what these hazards are.
Yeah, thank you so much for the invitation to be here today, Zita. I will share some slides here so that we can learn a little bit about what the earthquake hazards are like in the state of Washington, and also what our what this new thing called ShakeAlert and earthquake early warning actually is, and how does it work. So, you know, we all know that there's potential for earthquakes in Washington. And the first thing I just want to really emphasize is that earthquakes actually happen here all the time. We don't feel most of them, but this is a map and it just shows a dot. The colors actually depend on how long ago they were in time, but actually this is all earthquakes above magnitude of 1 detected by the Pacific Northwest Seismic Network's set of instruments that are spread out all over our state and actually all over Oregon as well, just in the year 2020. So many dots on there because we have constant earthquakes. Now at a magnitude of 1, 2, or even 3, people don't really feel those earthquakes. We're just reaching the threshold where people are likely to actually feel some kind of shaking around magnitude 3. And of course, the ones that are actually potentially damaging and of concern are much larger, typically magnitude 5 or 6 and above, but also very fortunately, much more infrequent, and we don't see them very often. But earthquakes are going on around us all the time. And actually one of our jobs at the Pacific Northwest Seismic Network is to detect all of these earthquakes, report on their location. When you hear an earthquake happen in a particular place and the epicenter was here and the magnitude was such and such, that's us. We're the ones who do that through the seismic network that we have. But of course, you know, this is all the kinds of earthquakes that are mostly not felt. A few of these were felt by people and maybe even reported on the news. But we also actually have significant earthquakes in our region. Here's a question for everybody to just ponder for a second. What was the most damaging, meaning the costliest earthquake in the US in the past quarter century, 25 years? You might think, oh, California, Alaska, somewhere. No, it was actually the Nisqually earthquake of 2001. And Nisqually happened 20 years ago and changed, just a little more than 20 years ago now. It was a significant earthquake. Magnitude was 6.8. It occurred pretty deep to a seismologist below our feet, meaning about 30 miles down in the Earth's crust, directly below our feet. But the seismic waves come up to the surface from the fault, and that's the shaking that causes damage in that earthquake. And fortunately, only one person lost their life, and that was through a sort of a related collateral, not directly through an injury. Some people were injured though in that earthquake, a few hundred, and of course, quite a lot of property was damaged and lost. And in these previous events that were very similar to the Nisqually earthquake in 1965 and 1949, those sound like a long time ago, but that tells us that these same kinds of earthquakes have happened in our region, specifically in the Puget Sound, and even more specifically, actually, mostly in the southern Puget Sound region, kind of between, Chehalis and Seattle or so, periodically every few decades. And that's the you know, in some ways, the most difficult part about earthquake preparedness is most of the time we feel nothing happens, but when they come, they can be sudden, essentially without warning, and also potentially destructive. So all of these are events that took place just in our region over the past 60 or 70 years or so. And if you look back even further in time, before we had seismic instruments to measure these things, big earthquakes have occurred in our region. Most of the biggest ones in our region have actually occurred offshore, and you hear about these offshore earthquakes from time to time, especially down here in this very active zone of plate kind of collision and convergence off of Northern California or up off of Vancouver Island. But those, for the most part, are not very concerning on land. The ones we just talked about, plus the 1872 earthquake over around Lake Chelan, are the biggest ones we know about in our region. Now, everybody's heard about the big one and the potential for a very large, giant earthquake and potentially even tsunami to go with it off our shores. And that is an earthquake that we have, maybe you even heard the story, that based on a lot of incredible scientific sleuthing, you know, geologists studying deposits in the soils, in the ground, and Native American oral tradition and oral histories that we know of from the coast, the potential for a giant earthquake at the shoreline. Notice that there's no dots on this map because the last one that happened was in 1700, 321 years ago. But we really have very good scientific evidence that there's the potential for that to happen again, and everybody's heard about it. So in fact, you put it all together, and in our region, there's really multiple sources or multiple types of faults that are potential earthquake hazards to us. And this is a little sort of cartoon version of what the plate tectonic system looks like, with the plate at the bottom of the ocean actually sliding beneath North America there. And the boundary between those two plates is the offshore subduction zone fault. So that's a fault that can slip, both create a very large earthquake up to magnitude 9 in scale, as big as the largest ones we've really seen on the planet, like the one in Japan 10 years ago in 2011, and with the same kind of accompanying potential for a tsunami. So that's pretty scary. There's a potential for a very large earthquake. We know something about the past history of those earthquakes, again, from geology. And so we kind of have a calculation or a conclusion so far that they come on the order of every 500 years. It's been 300 years. They don't come in lockstep. So the potential for such an earthquake to occur is really there. It could, happen in the near future, but it could also happen in the pretty distant future with, reasonable likelihood matching this sort of data from the past. So we kind of say there's a 15% probability or so of that happening off our shore. And it turns out a large offshore earthquake down a little further south in Southern Oregon to Northern California has a little higher probability. So that's 15 to 25%. Those ones that you may have heard of from faults like the Seattle Fault, the Tacoma Fault, the South Whidbey Island Fault are much shallower earthquakes and much closer to us. That's bad, right? Because they're close to us and therefore afford less opportunity for the waves to dissipate and weaken before the shaking gets to our region. But they probably only reach about a magnitude 7 or so, and there's a much smaller probability assigned over 50 years of something like that happening. So potentially in our lifetimes, something similar could occur. And then the Nisqually type earthquakes are these ones that actually occur down deep on the plate, but deeper below our feet. And those are clearly the most common. There's this high probability, 85% or so, that could happen again. So we have these different sources of earthquakes. They give us different amounts of time from when the fault slips till the seismic waves would get to a person in any particular location in Washington state, east, west, north, south, wherever. And so they present different kinds of hazards. Preparation for these earthquakes is key and important in all the ways we're going to hear about tonight, including preparing yourself and your family, making sure that building construction is up to snuff and all of those things. I'm going to talk specifically, though, about the potential for advance warning, just of a matter of seconds to maybe as much as a minute before one of these earthquakes actually has shaking that reaches you. And that's this earthquake early warning system called ShakeAlert. So what is ShakeAlert? What does this mean? First thing I want to say is it's not earthquake prediction. It has nothing to do with detecting the signs that an earthquake is coming and giving an advance warning. Unfortunately, our science does not allow us to do that in any way right now. There's lots of people on the internet who claim they're predicting earthquakes, and I can tell you right now that none of them, when they're talking about predicting earthquakes in advance, are doing it based on any kind of even remotely solid science today. I warn you off of those earthquake predictors. But what we can do is detect earthquakes as they're getting going. And if the earthquake is on a fault down below the surface somewhere, like a fault that's shown over here, the slip on that fault is the actual thing that happens in the earth. It sends waves out like ripples in a pond that are spreading out. Unlike waves, seismic waves, there's two types. There's fast moving ones that spread quickly, marked by the yellow sort of wave front here, traveling away from the fault. They don't cause much damage almost ever, but they do get detected by our seismic sensors, our seismographs that are spread out all over the region. Following behind them, moving much more slowly, still moving at a rate of sort of like a mile per second, but much slower than the fast ones, which are several miles per second, are the damaging waves, the shear waves and surface waves you may have heard of. So our sensors can detect those first waves before the second one has really gotten to a region. The close-in sensors detect it first. They send a signal which travels at telecommunication speed, vastly faster than the earthquake waves themselves, are computers that are housed at the University of Washington and are operated by the USGS, the US Geological Survey, national organization, as well as us together, detect them, can make calculations based on those first few detections that an earthquake is underway and send a warning out to cell phones, to broadcast systems, to all the different ways that we'll talk about for creating that alert. So all of this happens in a matter of just a few seconds, while the waves may take 10, 20, 30 seconds, a minute or more to actually get to a particular populated region. The amount of warning time potentially depends on how far away you are. So here's an example of how that works. Based on the Squally earthquake actually happening near Olympia. So the earthquake just happened. Those pink sensors are detecting it, locating, triangulating the position of the earthquake, calculating how strong the shaking would be over a region, and sending out an alert. That's the essence of the ShakeAlert system. All that happens faster than the seismic waves actually can travel to your location, if you're far enough away. If you're close to being right on top of the earthquake, there's less potential time. So how quickly can our system create earthquake early warnings? Turns out really fast. This map actually shows colors, and the color codes that are over here in blue are basically less than 10 seconds from the onset of the earthquake till the detection has taken place. And for the western parts of the state now, we're really at very short detection times. We're still adding new stations to the eastern part of the state where the earthquake hazard is lower and the population density is lower. But of course, we also want that protection to be everywhere. This is not bad over here, but it needs to get better. And we're continuing to add to our network. ShakeAlert is not finished in terms of being built. What is that network I just talked about? Well, we operate seismometers that are continuously recording 24/7 all over our state. Every pink triangle on that map there is a seismic station that we operate, about 238 of them just in Washington state. And we're actually adding all the time right now. That number may even be out of date because it's from just a few weeks ago. As you can see, we have lots more to add in the eastern part of Washington. And all that data, as I said, streams into the data center that's housed here at the University of Washington in Seattle. So we operate stations, in remote locations. We operate urban stations. We have one right next to PacSci down there near the Space Needle in Seattle Center. We have stations on mountaintops like up here near Mount Olympus. They are literally distributed all over our state to carefully blanket the whole region. So what happens to those alerts when they get generated? Well, they're potentially delivered to both sort of institutional users, as we'll see in a second, people that operate important infrastructure like power systems, transportation systems, and so on. But they can also get delivered directly to people, to the public right now, mainly via delivery through smartphones or through phones that can receive either Amber Alert style alerts, that's what's called WEA here, wireless emergency alerts, or the native software that actually runs the operating system specifically on Android phones, because Google and Android have implemented that. We hope that comes to all smartphones in the relatively near future. And so they're sent out in these various ways. And there's, that's the actual screenshot of the alert message for a large earthquake that Android would put out. It's actually already been operational in California since late 2019. We just went live with this on May the 4th here in Washington State. California experience has shown it works. You'll hear more from Dante in a few minutes, so I won't talk about how to make sure you have this available to you on your phone. But here's a real world example from California. September 18th of last year, a magnitude 4.6 earthquake occurred right in the middle of Los Angeles. Millions of people living essentially right on top of this earthquake. It wasn't big enough to do any damage, fortunately, but it was big enough to generate an alert. And the initial alert came out less than 5 seconds after the earthquake began. That left enough time for several seconds up to 20 or 30 seconds of alert time to all of the people in the whole Los Angeles region. Android sent out 2.2 million cell phone alerts out for that earthquake. System operated well. It didn't actually send out a wireless emergency alert because, for various sort of technical reasons of the federal law that governs this, the threshold for alerting for WEA is set at magnitude 5. This earthquake wasn't quite big enough for that, but Google and Android have chosen a slightly lower alerting threshold of 4.5, just barely past that one. So what can you do with a few seconds of warning? Doesn't sound like much, right? What am I going to do if I know 5 seconds or 10 seconds or 20 seconds before that earthquake shaking is coming? Turns out you can do a lot. You can do the direct personal actions that are the most important things: drop, cover, and hold on. Most earthquake injuries come from things falling on people, not from the total catastrophic collapse of buildings and so on. So drop, cover, and hold on is incredibly important action. You don't necessarily know that you have lots of time to, let's say, run outside the building. You want to drop, cover, and hold on in place. Also, those kind of automated actions I talked about can take place. Open the firehouse doors, make sure the trucks can get out. Close the valves in these water utility systems so the water that's going to be needed to fight fires or for people isn't lost after the earthquake due to broken pipes and such. Transportation systems, the Bay Area Transport BART system already uses ShakeAlert. It has for a couple of years as a pilot. That can come to much more of these systems. This is actually being implemented in the state of Washington. We have several examples. There's the water system in Sammamish in particular. There are a number of other water systems that use it. Stanwood Elementary School is our first big pilot that has it connected to the PA system so they can drop, cover, and hold on in school with Shake Alerts being broadcast to students with Shake Alert messages. And actually the emergency management department that Dante's from has this set up within their emergency operations center as well. And more of these are potentially coming all over the state. So that's where public alerting is for Shake Alert, and that's what Shake Alert actually is, an early warning that an earthquake has begun, and you can take those kinds of important protective actions because seconds really do matter. More information there with some contact. I can talk about that later, but thanks very much for your attention, and I'll pass it back to you, Zita.
Great, thank you very much. Really interesting, and I don't know about everybody else watching, but I had several questions come to my mind, so I just want to remind everybody that if you have a question, feel free to put it in the chat at any time. We may ask some questions of our speakers right after their segment, or we may save them until after everybody has a chance to go. But go ahead and share your questions throughout this evening. All right, Harold, that was a great overview of earthquakes and why we have earthquakes here in this area and some of the basics in the technology of ShakeAlert. I'm really happy now that we're going to look into not just that technology, but also how people understand risk. So up next is Dr. Ann Bostrom. She's a Weyerhaeuser Endowed Professor in Environmental Policy in the Evans School of Public Policy and Governance at the University of Washington. She studies risk perception, risk and science communication, decision-making under uncertainty. I feel like we've all needed that this year, especially, and is currently with funding from the National Science Foundation, the US Geological Survey, and the National Oceanic and Atmospheric Administration. And you also have studies in cognitive aspects of survey methodology, which I'm really interested about, engineering in public and policy analysis. And you also got your bachelor's at the University of Washington. So some great, strong connections to this area. I'm so happy you're here with us tonight.
Thank you so much, Zita. Pacific Science Center was part of my youth, so I'm very pleased to be here.
Excellent.
I will go ahead and get started then. Thank you for the opportunity to speak with all of you today. I am going to share some slides here as well and get started. Let's see, slideshow. Okay, can you all see that?
It looks great.
Great, thank you so much. So as Zita said, I'm Ann Bostrom. I'm at the Evans School of Public Policy and Governance at the UW. And this evening, I'm very happy to be able to share a few preliminary findings from what we call the ShakeAlert baseline survey for the US West Coast. I had the pleasure and privilege of developing this in collaboration with Dr. Sarah McBride and Bob DeGroot of the United States Geological Survey and the Joint Committee for Communication, Education, and Outreach Social Science Working Group, supported by the USGS. I'm grateful to acknowledge funding for this work from USGS to the National Science Foundation and the excellent survey implementation by NORC. So we ran a very short, compact 7-minute survey, and we surveyed over 1,000 respondents 18 years and older in Washington. Our aim was to collect responses that represented the whole adult population of Washington and to be able to distinguish meaningful and differences and changes in attitudes, knowledge, and expectations now and going forward. So I'll be skimping on methodological details today, even though, as Zita said, I'm very interested in them, but I'm happy to answer any questions you might have. In the next few minutes, I'm just going to highlight a few of our preliminary findings regarding pre-Pacific Northwest rollout experiences experiences and perceptions of earthquake risks and earthquake early warning, and expectations, hopes, and opportunities for ShakeAlert in Washington State. And as you can see, this survey, we ran the survey in late February, so before May the 4th. Given the time constraints, I'll focus on highlights from Washington State regarding earthquake experiences, perceived risks, perceived usefulness of ShakeAlert, and tolerance for false and missed alerts. And you can see there are other survey objectives here that I don't have time to talk about, but we have lots of other answers we can address. So first, earthquake experiences. Just over 80% in Washington report that they have personally experienced an earthquake. This chart shows the percentage of those with earthquake experiences who reported experiencing different levels of shaking. So here's the percentage on the side, and you can see the different percentages who reported these different levels of shaking that you may recall Harold just showed a minute ago. The modal or most common experience, as you can see here, was mild shaking, with few, under 20% total, reporting having experienced strong or violent shaking. And you can see here the percentage, what people did when they experienced the shaking. The most likely reported response to an earthquake from those who had experienced one was that they froze. Over 40% reported that they stopped what they were doing and stayed put. Over 15% reported that they stood in a doorway, not recommended action, which was more frequently the case than the recommended action of dropping, covering, and holding on, while a few percentage reported immediately leaving the building, that is evacuating, also not recommended. As this shows, there appears to be an opportunity here for earthquake early warning to help encourage people to drop, cover, and hold on, but that may be effective only in conjunction with practice to build good habits. We also, as you may have seen a second ago, had other opportunities so people could write in what they did. And this gives you a sense of the kinds of things that people, the 20% or so who answered other, wrote into that open-ended response. Responses included such things as ran downstairs and under a table, or realized afterwards what had occurred. People spend often those first few seconds when they're frozen trying to figure out what's going on. So another indication of an opportunity for earthquake early warning to help people. Of the 80% who reported that they had experienced an earthquake, the vast majority, and as you can see, over 3/4, reported in response to this select all that apply question that they had experienced no injury, damage, or loss personally or socially from earthquakes, which was rather surprising to us. It means we have good codes. Moving on to perceived risk. Here, people were asked to what extent they agreed or disagreed with these statements. And you can see these 3 statements here. Half of all respondents agreed or strongly agreed damaging earthquake will occur in their city or town in their lifetime, although the modal response was neutral. And this scale goes from this lighter blue, which is strongly disagree, up to the darker blue, which is strongly agree. And so you can see that most of these responses are up here. Not shown here is the fact that those who had experienced an earthquake were more likely to agree or strongly agree than those who had not. 40% disagreed that a damaging earthquake might happen in their state, but not near them. And 70% disagreed that a large earthquake in their city or town would not impact their life. Those with earthquake experience more strongly disagreed that a damaging earthquake might happen but wouldn't happen near them. And those with the earthquake experience were also more likely to disagree that it would not affect their lives. So clearly experience matters. On to perceptions about ShakeAlert. We asked people if they had heard of ShakeAlert, and in Washington, 11% said that they had. So out of the sample, that was 112 people. 89%, that means, had not heard of ShakeAlert as of the end of February. We then asked them this select all that apply question, asking what they knew about what ShakeAlert does or guessed it might do, with the question tailored depending on whether they'd heard of ShakeAlert or not. So those that had heard of it were asked which of the following do you know to be true, and those who had not were asked their best guess about what ShakeAlert does. The majority, so here in the blue, you can see those who are said that they had heard of ShakeAlert, and then you can see in this stripy red those who had not heard of ShakeAlert, which is the preponderance of respondents. The majority think that ShakeAlert sends a warning that an earthquake is approaching, which is correct. But note here also that many hold that mistaken belief to which Harold referred that ShakeAlert predicts earthquakes, and that's here on the left here, which it does not do. Also notable and illustrating the needs and opportunities for continuing education and outreach is that only about a fourth understood, knew or guessed that ShakeAlert is operated by the United States Geological Survey. At that point, we showed people who had not heard of ShakeAlert this description of the system, which you've heard all about from Harold. This is available on the ShakeAlert website in case you're interested, with lots of other information about ShakeAlert. And then after that, we asked them this question about where ShakeAlert is available. So remember, this is the end of February, so ShakeAlert was not available at that time in Oregon or Washington. So I call this the flying car effect because there's a bit of the future is now in it. In late February, before ShakeAlert rolled out in Washington or Oregon, over half thought ShakeAlert was already available in Washington, and almost half of Washingtonians thought it was available in Oregon. And reassuringly, a majority understood that it was already available in California. As you can see, survey participants overwhelmingly in this question agreed or strongly agreed that ShakeAlert would enable them to mentally prepare themselves for shaking, physically protect themselves from shaking, enable them to protect other people nearby, and enable them to get useful information about the earthquake, even if they didn't feel shaking. The 11% who had heard of ShakeAlert were more likely to strongly agree than to be neutral on these statements. One could conclude that awareness of ShakeAlert made them more optimistic about its usefulness. In general, when we asked about false and missed alerts, people reported that they would still want to receive alerts, even if there were false alerts, which are shown here in blue, or missed alerts, shown here in orange. So the question was, if you knew that the ShakeAlert system could sometimes send a false alert to alert apps, would you still want to receive alerts? Or if you knew that it could sometimes miss an earthquake, would you still want to receive alerts? And you can see over 60% said yes, they would still want to receive alerts regardless. So there's a high tolerance for both false and missed alerts. And as the responses to this select all that apply question about missed alerts show, just under half reported that they would want to know what had happened. This was the most common response. Yes, there would be some annoyance, some worry, but some wouldn't care, and few would remove the app. We see a very similar profile for false alerts, though we see lower percentages overall on this question. So, earthquake early warning, ready or not? Not so scary earthquake experiences are the norm in Washington. Most have not experienced injury, damage, or loss from earthquakes. Duck cover hold on is not the typical response. Most people freeze. Earthquake early warning may be able to help close that information gap and trigger protective action. While only about half of Washingtonians think a damaging earthquake will happen in their area in their lifetime, the majority think it would affect them if it did. Only 11% had heard of ShakeAlert by February. Regardless, the majority believe it sends a warning that an earthquake is on the way. However, only a fourth think it's run by the United States Geological Survey. Half thought in February that ShakeAlert was available already in Washington, and large majorities of our fellow Washingtonians think ShakeAlert will help them protect themselves and others and give them useful information. The majority want ShakeAlert to tell them the shake intensity, information on additional hazards like tsunami, and guidance on what action to take. And these are findings I didn't have time to show today. And many, from a fourth to almost half, do expect ShakeAlert to be wrong sometimes, for example, arrive late. But nevertheless, as you saw, over 60% report that they would tolerate both missed and false alerts. The most common anticipated response to those missed and false alerts is that they would want to know immediately what happened. There's a demand for post-alert messaging. The majority have heard some guidance on what to do, for example, duck cover hold on, even if that's not what they do. And we also found in this survey that only a fourth had prepared a family emergency plan, and less than half that many had practiced it, which I'm sure Dante will touch on. The pandemic has not pushed away concerns about earthquake and other hazards. Washingtonians reported in this survey that they were equally or more likely to think, be concerned about, and prepare for other hazards like earthquakes because of the COVID-19 pandemic. Thank you all for your attention.
Thank you, Anne. Okay, I have to admit that when the Nisqually quake struck in 2001, I was in a room with a group full of people and the shaking started. We didn't hesitate, but we all went to the doorway. And then, as if one, we all stopped, turned to each other, and said, "Table." And then we all went under the table simultaneously. So, yeah, that practice to get that a little more ingrained, I can see as a good thing to do. Absolutely.
Excellent illustration. Thank you, Zita.
Yeah, I definitely, as you were going through, I was thinking about how I would have answered if I was taking that survey. And I'm sure a lot of our audience members were thinking about that as well. Excellent. Thank you, Anne. All right. Well, let's dive a little bit more into how to get ShakeAlert and how to know about it and how to prepare. And for this, I'm excited to welcome Dante DiSabatino. He's the Earthquake Early Warning Outreach Coordinator for the Washington State Military's Department of Emergency Management Division. That is an amazing title, Dante. But you're also responsible for the public education, messaging, and outreach of the ShakeAlert early warning system, including focusing on emergency preparedness, public alerting, and protective actions to take when receiving these alerts. And I know that you work with a really wide range of audiences, including federal, state, tribal, governmental, and private sectors. Thank you so much for joining us tonight.
Yeah, thank you so much for having me. And I'm just so thankful to be here with an amazing group of people. And I'm very excited to help you know what to do to not freeze, to drop cover and hold on, and to talk a little bit more about that today. But my name is Dante DiSabatino. I'm the Earthquake Early Warning Outreach Coordinator for Washington Emergency Management Division. And today I'm going to tell you a little bit on how you can make sure that your alerts are turned on and also what to do to protect yourself. So on May the 4th this year, public alerting for earthquake early warning went live in Washington State. And as you can see, we had a little bit of fun with that to help get out the word, to make sure that you don't freeze, you drop cover and hold on, and you know what to do. So for this next portion here, we're going to talk a little bit about how you can make sure you can receive ShakeAlert powered alerts. Well, one of the ways that you can receive ShakeAlert powered alerts in Washington State is through the wireless emergency alert system. So if you have your phone handy, take a minute to grab it. We're going to go over a little bit of some instructions on how to make sure they're turned on. Now, most wireless carriers do have these already automatically taken care of for you. But when it comes to wireless emergency alerts, which is the same system that delivers Amber Alerts, it's possible that you turned them all off in case maybe you got an alert at 3 in the morning. So let's take a moment to check while we're on this webinar today. So if you have an Apple iPhone, the first thing that you're going to do is you're going to go into your settings. So you're going to tap settings, go into notifications. You're going to scroll to the bottom of the screen, and under government alerts, you're going to make sure that you tap to make sure emergency alerts and public safety alerts are turned on as well, just like you can see in the bottom left-hand portion of the screen. These are most likely already turned on, so this is just a check for your Apple iPhone. Now, for your Android phone, the options vary a little bit. So depending on the device or the carrier that you have, the location of these options might vary. So one thing I would recommend doing is to use the search function in your settings to find emergency alerts or public safety messages. It also might be within your text messaging app platform as well. What you want to do is if you look on the right-hand side of the screen, this is how it might look depending on your phone. You want to make sure that all alerts are turned on. So extreme threats, severe threats, and public safety messages are turned on as well. Now, I will be sharing some links and at the end of the presentation as well, but you can also check at mil.wa.gov/alerts, like Harold mentioned as well, just to get a little bit more detailed instructions, including some videos that we've had uploaded to help walk you through. Now, what will it look like? Well, there's two, depending on your phone's language setting, it's either going to say one of these two things, that there's an earthquake detected, to drop cover and hold on and protect yourself. So just like in Harold's presentation at the beginning, where you hear that notification sound, it's going to behave, look, and sound like an Amber Alert, but it will have these messages on there as well. Now, the Android operating system has a built-in feature too. So this is on top of wireless emergency alerts. To make sure that these are turned on, they already should be, but you want to make sure two things. One, that your location settings are turned on, and two, that earthquake alerts are turned on. So if you go into the location settings on your phone for an Android user, you to make sure location's turned on, earthquake alerts, and also you can see what a demo might look like just to test it out as a sample, as you can see in the image that's on the right-hand side of the screen. So let's talk about first what you don't want to do if you feel shaking from an earthquake. Number one, you do not want to try and run or get up and go into a doorway. One thing you want to keep in mind is that a lot of injuries, and most of them in fact, are caused during an earthquake while moving during the shaking or being struck by falling objects. So I'm going to show you a short video here in a minute of what not to do and showing what could happen. So in this video, you see folks sitting. The first reaction they are having here is to get up and run out the door. You see this gentleman has a baby in his hand, and whoa, this is dangerous stuff. Definitely, we're not sure what happened to the folks outside, but if you look in the bottom part of the screen here, you can see if they stood underneath the desk moved, but if you dropped, covered, and held on, that you might have been okay to protect yourself, minus a couple of small debris. So let's talk about what happened in 2001 here in Seattle. So here is a perfect example in downtown Seattle. I think it's in Pioneer Square, of what's called an unreinforced masonry building. Here's a perfect example of why you do not want to run. You want to make sure you drop, cover, and hold on, because you certainly wouldn't want to get hurt by the falling of these bricks throughout Seattle or wherever you might be, or falling glass as well. Now, when you feel shaking, or if you get an alert, you want to make sure that you take these actions to drop, cover, and hold on. And there's a couple other things too. I mean, you might be anywhere. You could be shopping in a grocery store, sleeping, driving your car. So if you're sleeping in bed and you wake up, you want to stay in bed. You want to hold on and protect your head with a pillow. So don't get up and move. If you're outside, you want to stay away from buildings, walls, and power poles. If you're driving your car, stop where it's safe and turn on your hazards and stay in your vehicle. If you're in a wheelchair, you're going to lock, cover, and you're going to hold on to protect your head. And no matter where you are, still drop, protect your head, and stay there until the shaking stops. So here's a great example from the earthquake that happened in Alaska a couple years ago, what you should do. So immediately, we're drop, covering, and holding on. And this is emphasizing how the ShakeAlert earthquake early warning system, that those seconds could actually really come in handy. You don't need a lot of time to drop, cover, and hold on. And this is the protective action that has been proven to really protect folks and to save lives. Now, we have another risk in Washington state too. If you live along the coastline, there's a couple of important tips to survive the tsunamis that can come as well. So once shaking stops and it's safe to move, you want to make sure that you grab your go bag. Now, if you want to learn a little bit more about how to protect you and your family, to get kits overall for earthquakes and other hazards, you can go to our website, which is mil.wa.gov/preparedness. We have a lot of great tips, and I'm happy to share a little bit more. But you want to grab that go bag and head for your tsunami evacuation route. Be prepared to walk, because that evacuation route might be blocked or damaged, so you might not be able to drive your car. And once you reach high ground, you want to make sure you stay there. This is because tsunami waves may continue for 24 to 48 hours. So do not re-enter this tsunami inundation zone near the coast until local authorities do declare that it's safe. So I did give a lot of information about how to protect you and your family. So number one, if you still have that question, how do I sign up for alerts? Well, this is the way. Go to mil.wa.gov/alerts. If you want to learn a little bit more about ShakeAlert and the companies that offer products and services, you can go to our website, mil.wa.gov/earthquakes. You have our alerts page. And also, in case we can't get questions answered by me during the webinar, we do have an email here, public.education@mil.wa.gov. And feel free to follow us on social media. So that is what I do have for here today. So thank you very much. And remember, if you're prepared, you can survive. And seconds do matter to protect you and your families. So thank you so much.
Excellent, thank you. And I love the Star Wars connections to it. May 4th was a very nice day for the rollout.
Yes, it was.
Dante, I do actually just have one quick follow-up question for you. I think that video was pretty explanatory about why going under a desk is really good and why not going outside. Not doing that is really good. But what about interior doorways? Someone was asking on the chat, because that for many, many years was what you were told to do during an earthquake. What are some of the hazards of being in an interior doorway?
Well, ultimately, when you are standing, that's the issue. When you're standing, you could still fall down and hurt yourself. Ultimately, if you're going underneath a desk or a sturdy table and holding on to that, you can actually be able to brace yourself to be more safe. So ultimately, that is the recommended action to do, because you certainly don't want to fall down in the process of standing up in a doorway itself.
Yeah, I also saw that doorway in that video swinging open and closed quite a bit as well. So you probably just take a little bit of a pounding in there too.
Yes. So you just want to be careful. Yeah.
Well, I have some more questions for you about preparedness, but we'll wait until the end to ask you those, because I want to introduce our next and final guest, Mariah Jenkins. Mariah is a member of the research and operations team for the U.S. Geological Survey. And in this role, she assists with managing the ShakeAlert's communication, education, and outreach program, as I said, with resources focusing on diversity, equity, and inclusion. Mariah's graduated from Pfizer College with a BA in geology. Excellent, love it, me too. And environmental analysis with an emphasis on environmental equity in cities and urban environments. And her current research focuses on accessibility and earthquake early warning education and communication, and specifically in museums and science centers and other free choice learning institutions. Mariah, thank you so much for joining us today.
Thank you so much, Zita. Let me get my screen going here. Okay, yes. Thank you so much. I really appreciate the opportunity to share some of our work with you today. Again, let me move this right here. 1 second. There we go. Okay. So, hi everyone. Again, my name is Mariah, and I'm a research assistant with the U.S. Geological Survey, and I'm a member of the research and operations team of the U.S. Geological Survey's ShakeAlert earthquake early warning system. And the primary focus of the projects that I work on are related to communication, education, and outreach. And today I'll be presenting on our work related to considerations for creating equitable and inclusive communication campaigns as it relates to ShakeAlert earthquake early warning. And this work is absolutely a team effort and would not be possible without the support of my co-authors, Sarah McBride of the U.S. Geological Survey, Meredith Morgo, and Holly Smith of the University of Oregon. All right, so what brings us here? We've already had a little bit of an overview, but can't hurt to reiterate some things. So ShakeAlert is the earthquake early warning system for the west coast of the United States. This system is managed by the USGS and is currently operating in California, Oregon, and Washington. And the USGS has been developing the system for many years with partners from state governments, universities, and private foundations. The system is made possible by the hard work of many different people from many different organizations. And ultimately, the system aims to mitigate damage from earthquakes by notifying individuals and automated infrastructure systems about shaking from an earthquake that's already in progress, right? So potentially giving us just enough time to slow down a train to prevent derailment, or closing valves to protect a city's water system, or giving individuals just enough time to drop, cover, and hold on. And then you all saw this animation already today, but it just shows that P wave moving and then the S wave, and just kind of kickstarting that data processing. So what does earthquake early warning have to do with diversity, equity, and inclusion? And the short answer is everything. Earthquake early warning systems, just like any technical system, don't operate in a vacuum. The 2019 Global Assessment Report on Disaster Risk Reduction cites earthquakes as the most damaging natural hazards globally, causing billions of dollars of damage and killing thousands of people. Yeah, so in the US alone, over 143 million people live in areas where damaging shaking may occur, as seen in this hazard map included here. with over 50 million of those people living in Washington, Oregon, and California. And research shows that risk perceptions and preparedness behaviors are often shaped by identity and demographics such as income and education and race and ethnicity. So identity really matters when we're talking about preparedness. So when we're thinking about mitigating risk, we have to not just consider, but really prioritize our most vulnerable communities. We have to talk about race and ability and income inequality and so much more. So as earthquake early warning expands, access will absolutely be a defining measure of its success. So in our project, it's sort of threefold here. The first was just a literature review on earthquake early warning systems. We spent some time reading about preparedness communication and social vulnerabilities more generally. And then we offered two key theories that inform social vulnerability in context of ShakeAlert. And the two that sort of rose to the top here were relationship management theory and mute group theory. So from there, using our literature review and those key theories, we provided a set of questions for the agencies managing campaigns in order to identify silences. So with that, through our literature review, we briefly explored these clusters of variables while recognizing that these are all intersectional and really complex. So the first in that cluster is race, ethnicity, and language. So we reviewed work that highlighted how the US has historically upheld oppressive and exclusionary policies that have had real consequences for vulnerable populations during and after disasters. We spent time looking at work related to how physical and mental access and functional needs folks have very specific communication needs. And there's a huge range of ways to meet those. And in addition, we looked at income inequality and how socioeconomic status may influence how people can respond to and ultimately recover from a disaster. And we also spent time looking at infrastructure and housing and how things like home ownership shape wealth, which influences infrastructure. And this has just long-term implications for shaping bigger disparities. So we acknowledge that these factors exist, and there's other things that we could look at in the US as well. We could consider immigration status or incarceration status or family structure, among many other things that shape vulnerability and therefore could be a consideration, which is beyond the scope of this immediate work. And we also know that each of these variables listed constitute entire bodies of literature and should be fully discussed and integrated into our early warning campaigns. So additionally, we looked into one other consideration, which was not necessarily a vulnerability, but it's definitely something, a factor to consider. So we specifically looked at diversity within groups of folks who develop campaigns. So we looked at one specific study here too, highlighted how emergency management in the US is largely monolithic. It skews mostly white and mostly male and mostly folks older than 45 years of age, with 80% of survey respondents in the 2014 Weaver study showing that folks identified as such. We also know that geosciences as a discipline has had challenges and has seen very little change over several decades in terms of diversity, with an average of 86% of all PhDs in the geosciences being awarded to white students, which does not align with the US population, race, and ethnicity composition. So given the lack of diversity to reflect the communities in these groups that folks seek to serve, some argue that campaigns can be jargon-filled and create echo chambers as a result, leading to discourse that may not actually reflect what the publics need. So with that in mind, we decided to develop a reflective framework of sorts. So we highlighted two theories that offer an exciting entry point for developing more reflective campaigns. So the first theory here was relationship management theory, which really highlights the importance of the relationship between organizations and its publics. So some of the questions we could ask ourselves include, is our language inclusive? What are the demographics of the people that we're communicating with? And do we have developers and scientists and emergency managers who reflect those demographics as well? The second theory here is mute group theory, which emphasizes the importance of including voices that are marginalized. We know that in social hierarchies where some groups are privileged and others are not, those who have that privilege have the ability to control discourse for both the dominant and non-dominant groups. So questions that we can ask ourselves to better inform our work would be, who might be left out in terms of access to information about earthquake early warning? Where are our silences? How can we amplify the voices of people with different experiences and needs via our work? And then of course, these things are powerful in tandem. There's a ton of other questions here too that we can consider, but another two here are, can people access our campaigns, or are we relying on technological privilege? And have we spoken directly with the communities that we hope to serve and cultivated a two-way flow of information? Are we learning just as much as we are teaching, which I think is a very important thing to consider. And this work ultimately aims to create an engaged space for relationship building and increased community preparedness for earthquake early warning systems to achieve inclusivity and equity, which are very essential components. So without diverse voices included in the production of risk information, individuals and communities may continue to be marginalized and excluded from our work. In order to reduce risk, we must continue building relationships with vulnerable communities and learn about the unique challenges that folks face and really prioritize the communication needs of our most vulnerable publics. Hopefully these questions will inform our outreach and our leadership and current long-term project mapping and goal making we're doing. So this work only begins to scratch the surface of how we can better explore research and practice and more fully consider vulnerabilities and earthquake early warning in our associated communication campaigns. So future work should continue to explore DEI, diversity, equity, inclusion, and specifically it'd be interesting to do work related to usability and protective actions. So I hope that this brief work just offers a starting point for a much larger discussion on these really essential issues. So thank you all so much for your time today.
Great. Thank you so much, Mariah. You know, one of the things that I was most excited about when we were talking about doing this panel tonight was that we're starting with a very much a physical science, a geological science, and we're getting into the technology, but also into the social science and how people perceive risk, but how also do we make sure we're serving everybody in all of our different communities that would be impacted by a large earthquake. And so I really love this approach, tying so many different aspects into the central question of earthquake preparedness.
Yeah, it's been so great to hear the other presentations too and see how we're all coming from different dimensions. And I think that just gives you a little bit of an idea of how interconnected the work that we do is. So yeah.
That's great. Well, we have so many different voices to share tonight and coming from these different angles. So let's have all of our panelists come back now. And this is the chance for everybody who's been watching to ask any questions you have about, you know, maybe a question for Anne is how she goes from a undergraduate in English into the risk assessment, you know, person that she is, or Dante's favorite Star Wars character, or anything about emergency and earthquake preparedness. I think, Harold, I'm actually going to start off with a question for you. It goes back to one of your initial statements about how this is an earthquake early warning system, that an earthquake is already happening versus a prediction system. And so my question actually for you is, what scientific breakthroughs would need to happen for us to actually have a prediction system in place? And is that even scientifically possible?
Yeah, that's a super question. And sometimes people describe earthquake prediction as the holy grail of seismology, right? Because of course, there are things we could do if we had it. There's been work on for decades and decades in seismology focused on that question, and there have been a lot of you know, hypotheses, theories put forward that something that would work that have turned out not to be so, not to actually have any usefulness in predictability. Earthquakes are really different from a lot of the other natural disasters like volcanic eruptions, which not every single one, but most of them tend to have a bunch of things that happen that sort of show us the volcano is building up to the point of actually having an eruption. So like Mount St. Helens, actually the PNSN was the organization that had the seismometers out that showed 2 months before the eruption that it was going to occur. Hurricanes, we see them coming, right? All of the different kinds of things. Earthquakes are different. We don't have, there are foreshocks before some earthquakes. So sometimes, an earthquake happens and even a series of them, and then a big one occurs. And so looking backwards in time, you can say, oh, clearly that was a foreshock sequence. But unfortunately, we don't know it's a foreshock sequence till the bigger one happens. And since smaller earthquakes happen all the time, that's not really predictive. The science is showing us actually for the very largest earthquakes, the ones like the offshore tsunami creating earthquake, like in Japan, that there have been some really intriguing precursory signals, what we call slow slip events, ways that the fault looks like it was starting to modify its behavior just before the earthquake, or in the several days to weeks, even months before the earthquake. For a few of those earthquakes, that's actually the most promising avenue for earthquake prediction research right now, but it seems to only be detectable by very modern instruments and only for the largest ones. So not to be too long-winded about it, but just we need more events so that we can build up our understanding of those things. I think the answer, at least for the big one, the Cascadia big one offshore, is we need a lot more of our observational stations and instruments actually underwater off the coast, because that's where the earthquake's going to come from. We need a stethoscope right on the fault out there. Putting instruments on the sea bottom is a lot more expensive than putting them on land. So I'm optimistic that we may make headway in earthquake prediction, but it's going to be a long and slow and painful process probably to get there.
And I can't imagine that those offshore monitors are easy to install.
That's right. Cables on the seabed and everything else. So yes, lots of money, but the potential to help us is enormous too. And the costs of these events are enormous.
Yeah, excellent. Thank you so much. That's a great explanation. And I guess for now, we'll have to be okay with the early warning versus prediction system. It sounds like we're a little ways off from that still. And you had commented that many of the respondents said that they wouldn't be terribly upset with like a false alarm or a missed alarm with your survey. Did you at all get into how many false alarms or how many missed alarms would be tolerated before that perception changes? I was just thinking a little bit about Harold's example with knowing Mount St. Helens and having a couple of months, but there was a lot of challenges and that, a mix of emotions of people who were living through that experience and having those different warnings before it was known what it turned into.
Yes, this reminds me of when I got my first yellow amber alert on my cell phone, and that was really exciting. And then after about 5, I turned it off. So we did see in our open-ended responses that people said, well, if there were too many of them, I might start to get tired of them. So this is where we really are looking forward to learning from the longitudinal survey that we hope we will be able to conduct in going forward to see how people's attitudes change over time. There is some suggestion that people do become a little bit less tolerant over time. That said, we think that that kind of tolerance can be maintained as long as they know what's going on with the system. So we have advocated, and USGS is working on this post-alert messaging system where USGS makes it a point of letting people know right away what happened. Was there really an earthquake? If you didn't feel it, did somebody else feel it? Was it just offshore and mistakenly located? How are we doing on improving our estimates of the magnitude of the earthquake? That kind of thing. We think that kind of information will help this become a reinforcing positive developing system where the system is improving over time and people's trust in the system is appropriately improving over time. So, good question.
And with such a giant network across the state, also having that little explanation of why is just such a great window into how real-time science works.
Absolutely.
I love that. I think I might be more interested in some of those context notifications than the actual notification itself.
Yeah, if I could just add a nugget to that too, is we think a lot about what level of earthquakes should we make alerts for. And the idea is ones that, certainly we want to protect people from damaging shaking, but also maybe just alert people if it's one they're likely to feel, even if not damaging. And there's a risk of too many false alerts. There's also a risk if we never alert until a big one comes and it's, 5 years, 10 years more before people even get the very first alert they ever get. And that's when the big event is happening. So a little bit of sort of, ones that give people reminders, almost like drills, is probably pretty useful. Now, of course, we prefer they're not false, but just smaller earthquakes. but that's a factor.
Yes, and we did find in one of the findings that I didn't show is that people are interested in being alerted for earthquakes that can feel whether or not they are damaging. So there is this interest in sort of knowing what's going on and being able to interpret the shaking that they're feeling.
Yeah, I've definitely had moments in my life where I'm like, was that an earthquake I just felt or a big truck that went by? And to have that real-time notification would be pretty great, and cease that wondering that happens. We've got some great questions that are coming in on the chat regarding the notification system and the cutoff threshold itself. So I'm just going to throw these out and see, which of the four of you would like to take it. So Kara would like to confirm that this alert only goes out at a magnitude of 4.5 or greater. Is that correct? And how was that chosen, what that cutoff would be?
Yeah, it's actually, there's a combination of the magnitude of the earthquake and the expected intensity of the shaking at the location you're at. So you think about it, an earthquake just has a magnitude. It could be a 5, a 6, a 7, whatever. But if it's far away, of course, that might not shake you at all, or just lightly. If it's close in, it might be more strong. So the thing we call intensity is dependent on where you are relative to the earthquake. So the thresholds are set up for this 4.5 magnitude and an intensity that is large enough that most people, or a large proportion of people in a given area, are likely to at least feel the earthquake. And those are selected on those same criteria I just sort of talked about. Is we'd like to alert people when they're going to feel shaking, even if it's not necessarily likely to be damaging where they are, but not over alert them for earthquakes they're very unlikely to feel.
And do you think that is it possible to have a feature in the future that allow you to set your own threshold for the alert so that you pick the magnitude that it's cut off or included?
It actually may be possible, yes. There's settings that right now the delivery system can choose what threshold to set internally in their system. And then there's the possibility that they could include a sort of a user-defined button. Don't bug me unless it's a 6 kind of thing versus something smaller. But that's not implemented in any of the current implementations.
I also want to comment on the chat that several of you are getting some shout outs by name, and you have some fans, definitely. So Robert says, thank you so much, Mariah. We've got some links that have been added. A fan of Anne has jumped in as well. Thank you for sharing. So, and great job from Jenny to all four of you, and I definitely agree. So now we've got some situational questions. So here's a which is better question. So the shaking starts. Is it better to go to an interior doorway or hang out under a table but next to a giant window?
I'll take this question. So between those two options, ultimately, you still want to make sure that you're drop covering and holding on under a sturdy table. So the thing about the doorways, which is really interesting, is the doorway is no stronger than any part of your other part of your house. So if you're drop covering and holding on underneath that table, you still should be fine. I mean, it's always important to be aware of your surroundings too. But ultimately, it's that moving around that moving around during that shaking that can be very dangerous. So I still would take the table, but being cautious and aware.
Mm-hmm. So, wow, I kind of want to ask now, what's the largest earthquake that all of you have been in? And where were you when it happened?
So this is an interesting question for me because I'm from Florida. So I've lived in Seattle for a couple of years and I've not experienced an earthquake before. So this is a really interesting position to be in. But ultimately, I will be taking my advice, and I know that the folks that I work with have given me a lot of anecdotal evidence of what to do as well.
Well, I grew up in Seattle, so I experienced the earthquake, was it 65, is that right? I was not here during the Squally, but I was living in Atlanta. So I experienced a very rare earthquake in Atlanta. And it was just like you, Zita. I thought it was a truck approaching. I mean, I knew there was a slight potential. I was working with engineers who work on earthquakes at the time, the Mid-America Earthquake Center. So I knew there was a potential for earthquakes, but I really didn't expect one in Atlanta. And my first thought was, well, I stood up, I froze, and I was like, oh, this is an unreinforced masonry house. I was like, anyway, and then I was like, well, that maybe it's a truck, you know. And by that time, it was almost over. But I didn't do the right thing, and I was just kind of blown away that there would be an earthquake in Atlanta. So I could feel it, but it really wasn't clear what it was.
Excellent. Thank you. I will, Kara asked the question about interior doorway or under a table. And from the Squally quake, that was my choice. And I was under the table and I was next to a very large window. But I have to say that just facing away from the window, but being under that table, definitely just in the moment felt like that safer spot. Yeah. I have felt one other earthquake and I did move because I was actually in the shower for that one. And that was not where I wanted to be in the event of an earthquake. So I did move on that one and relocated towards, a robe and some shoes.
So in the fall of 1989, I moved from Oregon down to Santa Cruz, California to start a PhD program in geology at UC Santa Cruz. Well, 3 weeks later was the 1989 Loma Prieta earthquake, the so-called World Series earthquake, which collapsed the Bay Bridge and the freeway in Oakland and all the things. We were about 12 miles from the epicenter of that on the campus of UC Santa Cruz. And fortunately, I was outdoors of the building that my department was in. I looked up at the building and saw the windows moving like violently and tried to walk up the path away from the building and was knocked off my feet by the strength of the shaking of that earthquake. And then we had continuous aftershocks for a long time afterwards. So that really actually directed my PhD project from sort of more kind of geological, how did the plates get where they are kinds of questions to more like, oh, this is actually happening today. This is not 50 million years ago. Earthquake science and modern, what we call modern as geologists, meaning present day tectonics and these kinds of things. It really turned me in that direction, that experiencing that event.
And a personal experience that really speaks to, these quakes can be strong enough to knock you off your feet. So getting down and holding on before it has that chance just again speaks to that preparedness and for this ShakeAlert.
Yeah. I've been thinking, I've grown up in San Francisco my whole life and have lived in a wide variety of places that have all been earthquake prone. Like I went to school in Southern California and then studied abroad for half a year in New Zealand, in Christchurch. So I haven't actually experienced a huge or historical earthquake, but I have been woken up by earthquakes just like growing up, but nothing really huge. And I think that part of growing up in a family where everyone had some major earthquake, most of my relatives were in the 1989 quake and all have some direct connections. I would constantly think about why aren't we talking about this? What do you mean this like giant event could happen? And just years have passed and you can casually tell me about how the room felt like it was swaying and how the sounds of an earthquake are so intense. Like a lot of the people I know and are close to have very vivid experiences, but fortunately, no.
There's something reassuring. I would think about getting that alert afterwards because an earthquake can be such a disorienting experience. So just have that little confirmation of this is what it is and what happened. Which takes actually to our next couple of questions regarding how the alert system works. So question number one, if you have the phone and you followed the steps that you did, I have an iPhone and I saw the government alerts and all three are put to green. Is that it? There's no other apps I need to do or nothing else I need to sign up for?
Yeah, that's correct. So currently in Washington State, the two ways to get them is through those wireless emergency alerts, checking through the Android phone as well. So you're good to go. So ultimately, those are the actions that you can take to potentially receive the alert if shaking is expected at your location. Of course, meeting the parameters that Dr. Tobin talked about today as well.
Excellent. So this next question, again about phones, and Mariah, it might actually be for you first, thinking about how we reach everybody in our community, because not everybody has a smartphone. So one of the questions that's come in is, if you don't have a smartphone, are you just out of luck? Or is there something else that you can do? And is there another way to get notifications?
Maybe I'll pass that off to someone else who works closer to the system itself. But as far as I know, it's mobile alerting is the main way that like the public more generally will receive an alert. There are other systems in other countries that have a wide variety of approaches that include like, well, there are, from what I understand, some public systems that have PA announcements. So there are, like in schools, for instance, there can be like a PA system. So for individual infrastructure or specific schools or institutions, there might be a wide variety of ways, but for the public directly, I believe it's on the phones. But
well, maybe this is, Mariah, maybe this is a future question then that I'll come back to you right after we dig into the phone question, is, are there just other, thinking about the future and not ShakeAlert specifically today, but in the future, when we're really prioritizing inclusivity and equity and having everybody get the messages, what has your research informed might be possible solutions in the future? But for now, let's address the, if you don't have a smartphone today, what can you do to be part of this and know about these alerts?
Yeah, so I'll expand a little bit on this. So on our website, we do go into detail, just like you mentioned, for your Apple iPhone and your Android, these smartphones. Now, depending on your wireless service provider, the wireless emergency alert system, it depends on how old your phone is. It's just, now for emphasis, the wireless emergency alert system is maintained by FEMA's what's called iPause system. Now there's different levels, different kind of amber kind of alert messages, public safety messages. Since it's all that same system, maybe we can see in the future better development when it comes for the from the wireless emergency alert side. Now with that said, I would, number one, check with your mobile phone provider, at least for the mobile phone alerting, to ask some questions, to check with the phone manufacturer as well. And ultimately creating redundancy in the ways that we see alerts, whether it's on your phone or if you're experiencing and hearing the alerts, just like Mariah said, on a PA system or around you. These are some future things that we might see. But that's what I would say for that answer right now.
Just to quickly add though, the WIA system does not require you to have a smartphone. Lots of phone handsets can receive WIA messages that are not smartphones as well. So yes, you have to have a device, and very importantly, you have to be within range of cell coverage. That's the biggest limitation of that.
So, Mariah, in the future, do you see, has your research informed ideas of what an alert system could look like that really is getting to everybody, regardless of the technology and the need of something like that?
Yes, that's definitely an area of research that we plan to further explore and understand the unique needs of just people in a wide, like all different places. And I also think that it's very, very particular to specific regions and cities and spaces. And yeah, I think the needs are very unique. So the solutions will also become more and more unique. But I think audio would be a huge way to reach a lot of individuals. So I think that's one thing that comes to mind for me, but I'm excited to see those areas grow as well.
We see in the responses to the survey, we see that the vast majority of people would prefer to receive an alert via their smartphone or cell phone, but we also see a really large interest in receiving notifications via TV or radio. And the issue is the speed, because as has been pointed out here repeatedly, you only have a few seconds usually for most earthquakes. And so the faster and we can deliver those alerts and the faster the technology permits us to share them, then the more likely we are to be able to use that kind of public broadcasting system to equalize opportunity and for everybody to hear it. They do post like radio and TV alerts in Japan, for example, on a regular basis. So that's not out of the question.
Yeah, we have somebody else commenting that they live in a place where there's no cell coverage. And so that smartphone notification system actually currently just isn't of use with them. So are there places they're suggesting and asking about like an air raid siren type event? And I think those are definitely present for tsunami detection. Is that correct?
You can go, Harold.
Oh, I won't comment on the last part. I'm sure Dante will about tsunami detection. So I think we are in an early stage where a lot of this stuff is developing. There is one of the partners of the ShakeAlert system that's a company that offers FM radio specific broadcasts. You can buy a device that's kind of like a weather radio type device. So people who are in areas without cell phone coverage can still potentially receive radio signals. Of course, if you have a direct internet connection, even if you're not in a cell phone serving area, then there's the potential for, let's say, an Android device to receive it because your phone can be on the wireless network as opposed to the cellular network, if you know what I mean, Wi-Fi instead of cell phone. I think what we're going to see is more and more of these systems become interconnected to that. There's another system that is not operational yet for ShakeAlert, but is being actively explored, I know, by the USGS, that will do that on television screen messaging, so that can take place as well. Just editorializing now, because this is not stuff that's actually in the works, at least as far as I know. You could think of all kinds of ways, all those smart speakers that people have in their houses, right? Can Alexa give you an earthquake warning, for example? Have no idea if that's in the works at all or coming, but those are the kinds of things we're all thinking about in the community of researchers who want to do, this thing that Mariah talked about that's extremely important, is reach everybody. And we all know that there's always the sort of 80 to 90% of the population that's relatively easy to reach. But we want to make absolutely sure the most vulnerable people in our communities have equal access to these kinds of systems. And that's the challenge going forward from here.
Well, that leads wonderfully into a question from Brian. So I'll just do it. This will be a quick round robin of all of you who would like to share. Do you each have an automated action or a technology for earthquake early warning system that you're most excited to see in the future?
Well, if nobody else is going to start, I'll start.
Yeah, and let's have Anne start.
When Richard Allen was first researching this, he had this screen device that showed, that you're here, here's the epicenter, here's the wave coming, and here's the countdown. And so there are a lot of questions about whether that is good or not, and it's definitely not possible with current current technology and the system. But I think it'd be, from a scientific perspective and from a curiosity perspective, it would be really fun to have that, to be able to see the epicenter, to be able to see what's going on and see the countdown to where the earthquake was approaching and at what estimated intensity and magnitude.
That's a great one. Mariah, would you like to go next?
I feel like the things that I'm really excited about, I know to some degree already exist. I specifically think about water systems and protecting water systems through just shutting valves. And they're such small actions that make a huge impact. So that's one of the things that I know is a reality that is already there. But yeah, I think that there's still so much to grow and learn. And that's also a cool a question to throw back to the people who are also watching. What are the cool ways that you could see your life specifically being improved, or your family's life being improved by unique technology there?
I'll go ahead and share mine. So this is a feature in some states for automatic actions. So imagine if our nurses and doctors were attending to a patient's very specific needs and care, and they had seconds to help secure that patient, especially thinking about COVID-19 and how it's impacting so many people. But if they had the automatic action, at least of, thinking about securing oxygen, important supplies, but also being able to pause sometimes life-saving and very delicate surgeries. I'm looking forward to seeing that technology expanding farther throughout our state, because it is possible and it is being done in some parts of the country.
I've got a really simple one. I want to see iPhone systems, Apple iOS, do what we've seen already with the Android system. And it might be worth explaining why this seemingly redundant thing makes sense. The wireless emergency alert system is great because it's the most universal, but it operates over the cellular network, and individual devices, their operating system can connect via wireless, right, via Wi-Fi in a way. And so there's actually some research that shows that the alert delivery can be faster and a little bit more reliable through the operating systems than through the WIA system, and give more information out. So, most smartphones operate on one or the other of two major systems in this country, commercial systems run by corporations. So anybody from Apple is listening, let's get that system going on the Apple phones.
Excellent. Okay, so to confirm, if you have a smartphone, there's the different settings to turn it on, and you'll get those alerts even if your ringer is off, correct? Okay. Are there going to be any test alerts planned just so that we have the peace of mind that it's operational and it's working?
At this time, there's no planned demonstrations, but it doesn't mean that there won't be. So right now we're not having any planned tests, but ultimately, if you do want to learn more, if we would in the future, we would be posting that on our social media accounts and sharing that on our mil.wa.gov/alerts page, which, by the way, I would recommend taking a look at for all sorts of different alert features, whether it's local alerting, tsunami alerts, a lot more to learn there.
Excellent. So we'll put that link in the chat also. Dante, if you just want to say that link one more time.
Yep. This is that mil, so mil.wa.gov/alerts. So this is where we have links to all of your local alerts as well and how to get them.
Excellent. So we put that in the chat at the start of the talk, and we'll add that to the chat now. So obviously, a great action to take is to make sure that you have that connection, you have that on your phone, you have those settings set to go. But there's a lot more actions we can take to prepare for earthquakes. So our final question for each of you, and I think I'm just going to ask you to just go in alphabetical order. So Anne, then Dante, Harold, and then Mariah, and then Zita right at the end. What is an individual action that everybody who's watching today should take in preparation of earthquakes?
Well, thank you, Zita. Well, one of the things that we've seen in our surveys is that people may have a family plan, but it's not common, and they've hardly ever practiced it. So come up with a plan. Look on the EMD website that Dante has shared to look at what might be in your plan, a reconnaissance point where you might go back and meet if something happens. Come up with a plan and practice it.
Absolutely. And just to further reiterate, it's also about building your kits. Times we think about not only our families, but it's really important to think about building emergency kits for our pets too. So lo and behold, we have a surprise guest with us.
I love props.
So
Oh, we lost your camera, Dante.
Just a moment. All right. Nothing like having a last minute technical difficulty on a live call. And,
I have a feeling it's going to be worth it though.
But so this is my dog Comet, and a lot of the things that I think about are not only the things I need to do to protect my family, but also to have kits for our pets. So this includes things like toys that they like. So this is Comet's flamingo toy, to having food ready to go as well. So having food to go, having all of the things that make them comfortable, so you're ready. So if you want to learn a little bit more in addition to some of the things that we talked about today, you can go to our website, mil.wa.gov/preparedness as well. So on that website, you can learn how to know your hazards, to build your kits, and to create that family plan that Anne was sharing as well. So thank you.
And I mean, the advice for your pets is great for the advice for kids. and for yourself and your own kid. Have food that you like and have some things that'll give you some comfort that you like as well. Perfect.
Absolutely. And you know, ultimately, I emphasized it, be prepared for the unexpected. Even if your video signal goes out right when you want to share with a whole group of people across the Puget Sound area. So thank you.
Worth it. It's great to meet Comet. Harold, you have a special guest too. Who
Yeah. Lulu was sitting on my feet while we were talking. So when Comet showed up, Lulu had to show up too. So I totally second everything that was already said, and I'll just add one more to it. You and your family, the closest people to you, maybe in the same place when the earthquake hits, maybe in different places, at school, at work, at home, wherever. Make a plan for what your meeting point is if, cell phones are down, you don't have an easy way to reach each other. Make a plan for that backup plan. Here's what we're going to do if we need to get back together eventually after the earthquake takes place.
Excellent. Thank you.
Yeah, I was thinking very similarly with the specifics on communication plans. And I know that one thing that's really important is making sure that everyone has the right contacts, especially kids or younger folks in your family or friends or whoever you live with, making sure that you have that contact list in place. And then also having a designated out-of-state contact, someone you can call who is not in your location, because those longer distance calls will likely be more successful to go through when you're trying to reach loved ones. So talking about who you'll talk to after an earthquake, I think, is a really big point to have a plan for.
Well, these are some great reminders. I used to have in the office some comfortable shoes and a rain jacket that just always were under my desk. I didn't always go to work with a rain jacket or comfortable shoes. And in case of an earthquake, I might be walking home. Now that I've been working at home for the past year, I realize that I need to put that back in my car and back in the office. So thank you for prompting me that at some point my life will be a bit wider in the community, and that preparedness is really important. Thank you all so much for joining us tonight. This was a fabulous talk and a fabulous range of actions to think about, and really appreciate the hard work that you've done to get the ShakeAlert system going. I know it's been many, many years in the making, and really great to see all the fields that have come to bring this together in service of our community. We hope that everybody viewing tonight has enjoyed tonight's program. We would love to hear your feedback about tonight's event, so please take a couple of moments to fill out a short survey that we'll be putting it into the chat here on YouTube. You also can sign up for our e-newsletter at pacsci.org/SITC, that's Science in the City, and you can support with a donation to pacsci.org/support. Lastly, as you've heard, a great action to take with your own emergency preparedness journey is to create a plan with your network. That might be family, neighbors, or close friends. Tonight's presentation can help you do that, and this can be a resource. We've got it on our YouTube page for viewing into the future, so you can share the link out to anybody else or just rewatch parts of it to get refreshed on the different aspects and the actions to take, and all the links will be present in the chat as well. Before we head out, I just want to thank all of you one more time for joining us tonight, for your amazing questions in the chat, and thank you to all of our guests for joining and for sharing the work that you're doing. Thank you so much, everyone, for being curious with us, and have a great night.
Thank you.